This video covers D3 transition events. The structure of this video is as follows: transition end event, transition animation chains, and the summary. Alright, let's get started. Transition end event. For this example, we will have the SVG rectangle increase its height from 100 to 300. This will elongate the rectangle along the y-axis. Because we do not specify a delay or duration, the animation will start immediately and take 250 milliseconds. For this example, we will have the SVG rectangle increase its width from 50 to 300. This will elongate the rectangle along the x-axis. We also add a transition duration to slow down the transition so that we can take a look at it. We start with a blank document with the D3.js library loaded into it. First, we create the SVG viewport and add the SVG rectangle. You can see the rectangle in the Chrome Developer Tools section. Next, we add the attribute value pairs to the rectangle to have the web page show the SVG rectangle. You can see the actual rectangle in the web page as well as the Chrome Developer Tools section. Lastly, we apply the rectangle animation transition where the width and height increase. You saw the rectangle transition from being a small rectangle to a large square. This has been a big step forward towards making data visualizations interactive. This one transition is able to modify two properties of the rectangle at the same time. What if we want to modify one property first and then a second property after that? D3 is built so that only one transition per element may be active at any given time. Not only that, if a newer transition runs on a given element, it cancels any prior transitions, even those that were scheduled but have not yet run, which means that in the example on the screen, the expansion transition will be canceled. Let's reset the browser and do the two transitions to see how one cancels the second one. First, we create the SVG rectangle and define its attribute value pairs. Next, we will start the first transition. Then, during the transition, we will quickly start the second transition before the first transition has ended. What this should do is cancel the first transition and run the second transition from wherever the first transition currently is. Let's start the first transition, now quickly the second. What you should have seen is the rectangle slowly expanding outward, and then as soon as we started the second transition, the expansion should have stopped, and then suddenly the rectangle should have shrunk. This is how D3 behaves when you try to create two transitions on the same element, one right after another. How then can we have two transitions on the same element? To the case earlier, how do we alter the height first and then alter the width second of the rectangle? Or in this case, how do we get the rectangle to expand fully and then contract afterwards? In order to stage the order of transitions, we go back to the D3 transition lifecycle. The lifecycle of a D3 transition is broken down into 4 separate phases. Because transitions happen over time, there is a sequence of recurring callbacks. Each phase starts when the previous phase has ended. During the transition end of the lifecycle, D3 invokes an end event. It is this end event that can allow us to build multi-stage transitions. The D3 selection.on method adds an event listener to each element in the current selection. In the case of transitions, we can have a D3 listener for the end event of a transition. In this example, we create the SVG rectangle and define its attribute value pairs. Then we define the same transition we have been using all along, basically that the rectangle will expand. What is new this time is the .each section that is highlighted. Here, for each element in the selection, we are going to listen to the end event from the transition. Once this happens, we will run the callback function we are defining here. Let's take a closer look. The first line is the each method that will apply a function to each element in the selection. The second line creates a new D3 selection using the this variable. Recall that in D3 methods, the 3 variables that are available to us are the D for datum attached to the element, the I for the index of the element in the selection, and the this JavaScript variable for the actual DOM element. Using this new selection, we define a transition to shrink the rectangle SVG shape over the period of 3 seconds to a smaller shape. Using a reset browser, let's take a look at the effect. First, we create the SVG rectangle and define its attribute value pairs. Next, we start the first transition, which, when it is done, will trigger the second transition. And with that command, you should have seen the first transition occur fully, then the second transition occur fully right after the first transition, which works well and is exactly what we wanted. The only new thing that we had to add was listening to the end event of the transition and using the this variable inside of the D3 each method to create a new D3 selection for the second transition. What if we want to add another transition after these two transitions? To add another transition after the two transitions, we would just add an event listener to the second transition that listens for the end event of the second transition. To add a fourth transition, we would just have to do the same thing. As you can imagine, this would quickly become unreadable due to the nested nature of inserting transitions in each of the .each methods. Luckily for us, D3 allows us to approach the issue of multi-stage transitions another way. Transition animation chains. With this code, we define a rectangle. Then, the height and width are transitioned at the same time. In the previous section, we covered how if we wanted to do one transition first and then another, we would have to attach an event listener to each event of this selection. This event listener would listen for the event end, after which it would then start the new transition. When D3 version 3.0 came out, transition chaining supplanted creating a new transition inside of the end event listener. This is a simple example of transition chaining. As long as the transition is chained to another transition on the same JavaScript command, D3 does the hard work of tying the transitions together so they will be seen as one multiple transition. This more complicated example does 4 transitions in a row, one after another. By doing this, we stay away from the jumble that end event listeners would have created. This example does 2 transitions in a row, one after another. What is different about this example is that each transition changes 2 attributes at the same time. So the first transition changes the height of the rectangle and color at the same time, while the second transition changes the width of the rectangle as well as the color at the same time. This should show you that you can make each individual transition as complicated as possible and still be able to chain the transitions. This example shows you that you can use functions within the transitions just like we have before. Here we use the index, though we could have used the ddatum inside of the function if the elements had data bound to them. The transition will change the height first and then the width. In each case, it will add the index number, which is 0, to 150. Let's take a look at these examples in the JavaScript console. For the first example, we create the SVG rectangle. Next, we run the simple transition. We see the rectangle height increase first over the span of 3 seconds. Then we see the width increase over the span of 3 seconds once the rectangle height has stopped increasing. Next, let's run the more complicated example that has 4 different transitions. We see the rectangle height increase first over the span of 3 seconds. We then see the rectangle width increase over the span of 3 seconds. We then see the rectangle height increase over the span of 3 seconds. And lastly, we then see the rectangle width decrease over the span of 3 seconds. Next, let's run the transition example that changes 2 attributes per each transition. We see the rectangle height and color fill change at the same time over a span of 3 seconds. We then see the rectangle width and color fill change at the same time over the span of 3 seconds right after the first transition is done. Finally, we run the transition example that uses formulas in the attribute method for each chain transition. We see the height change over the span of 3 seconds. We then see the width change over the span of 3 seconds. noticing, of course, the height defined and the width defined were the result of an anonymous function in the attribute definition section of the transition, which is fantastic because we now know how to chain multiple transitions so that they execute one right after another, and know that we can create complicated transitions easily. Let's go through one final example to show you many chain transitions based on data. First, we create the data. Then we create the SVG viewport. Then we create the circle elements. Then we define the attributes for the circle elements. Then we define a crazy function. This will be our function that details all of our transitions. Note that this changes the radius, the CX, the CY, the fill, the stroke, and the stroke width of the circle. Lastly, combining this video with the last video, we will trigger the transition when the circle gets a mouse over event. Now, when we mouse over each circle, we get to see the series of transitions in action. And with that, we have covered D3 transition chaining, how to use DOM events to trigger transitions, and shown how we can add many transitions together while having varying attributes of an element all transition at the same time as well. The summary. This video covered transition in the event, transition animation chains, and the summary.